Windows kernel exploits. Now that we've taken a look at how to exploit Windows services and protocols, let's turn our attention to performing or elevating our privileges on a Windows target, right? So this is the Windows privilege escalation section of this course. And to begin, we will be taking a look at Windows kernel exploits, all right? Before we actually get started with how to essentially elevate our privileges through the use of a kernel exploit, let's get an understanding of what privilege escalation is. All right, so privilege escalation is the process of exploiting vulnerabilities or misconfigurations in systems to elevate privileges from one user to another, typically to a user with administrative or root access on a system. All right, so again, I'll just be using a very simple analogy to explain this, right? So let's say I gain access to a system, and in this case a Windows system, and I realize that the privileges that I currently have access to are very limited, which means that I can't really do much in terms of data exfiltration or pivoting onto another system on that network. In order for me to do anything that requires administrative privileges, I will need to elevate my privileges to the privileges of the administrator user, or to obtain NT authority system privileges in the case of Windows, right? It's very important to understand what privilege escalation is and the various privilege escalation techniques that can be performed both on Windows and on Linux. And privilege escalation is a vital element of the attack lifecycle and is a major determinant in the overall success of a penetration test. And the reason for that is quite simple. If you're contracted to actually perform a penetration test on a company's network, and you only obtain initial access on one system, and you aren't able to elevate your privileges, well, you can't make your way through the network or obtain any data that's potentially damaging to the company. And again, a good penetration test or a good penetration tester is an individual who is able to some extent to be able to actually elevate their privileges across a network. And of course it isn't required, but if the network, if the actual company's network is secured properly and the hosts have been secured correctly, and you aren't able to elevate your privileges, well, that's just a testament as to how good the company has actually implemented implemented the security policy, or how good they're able at detecting attacks. But again, as I said, if you're working on a very simple network and you're dealing with with Windows systems, there should be at least one privilege escalation attack vector that you can use. All right, so after gaining an initial foothold on a target system, you will be required to elevate your privileges in order to perform tasks and functionality that require administrative privileges, and for obvious reasons, right? So the importance of privilege escalation in the penetration testing process cannot be overstated or overlooked. Developing your privilege escalation skills will mark you out as a good penetration tester. So this is pretty much one of the most important areas within this course for both Windows and Linux, because exploitation is fairly simple in that there are various exploitation vectors that one can use. And in addition to that, there are multiple exploit modules or exploit code available that can simplify that process. Now, given the fact that we're targeting the Windows kernel, we need to have an understanding of what a kernel is. Well, firstly, a kernel is a computer program that is the core of an operating system and has complete control over every resource and hardware on a system. So it really just acts as a translation layer between hardware and software and facilitates the communication between these two layers. So a kernel is essentially the core of the operating system and is responsible for various pieces of functionality like I/O, arithmetic, memory management, etc., etc. Now, what kernel does Windows run? Well, Windows runs a kernel called Windows NT. All right, so Windows NT is the kernel that comes pre-packaged with all versions of Microsoft Windows and operates as a traditional kernel with a few exceptions based on user design philosophy. And it consists of two main modes of operation that determine access to system resources and hardware. So this is very, very common. This particular architecture is very common on both Windows or Unix-based operating systems, where you have your user mode, whereby programs and services running in user mode have limited access to system resources and functionality. And user mode is typically, left for third-party applications or programs, that an end user would be running. You then have your kernel mode. Kernel mode has unrestricted access to system resources and functionality, with the added functionality of managing devices and system memory, right? So again, if we're targeting the Windows kernel, or we're trying to elevate our privileges by exploiting the Windows kernel, the reason why we're doing that is because if we get any code executed in the kernel mode or in kernel space, then we are essentially going to obtain, or that particular code or shell code will be executed with the highest level of privileges available on the operating system, right? So that's why we're targeting the kernel. Now, in terms of Windows kernel exploitation, kernel exploits on Windows will typically target vulnerabilities in the Windows kernel to execute arbitrary code in order to run privileged system commands or obtain a system shell. And of course, there are multiple vulnerabilities within the Windows kernel, as we'll be exploring shortly. And it's very important to note that this process will differ based on the version of Windows being targeted and the kernel exploit being used. So kernel exploitation is not a privilege escalation vector that I would recommend, just running in an ad hoc fashion, because as I said, once you start interacting with the kernel, there's an increased likelihood that you can cause system crashes, or that would consequently lead to loss of data, and it's not something that I recommend running in an enterprise environment, right? Now, Windows privilege escalation will typically follow the following methodology, right? So it's a two-step process, whereby the first step will involve identifying kernel vulnerabilities for this specific version of Windows that you're trying to elevate your privileges on, right? And we can do that, through the use of various tools or various automation scripts. And secondly, the second part of this process will involve downloading, compiling, and transferring kernel exploits onto the target system for execution, right? And this process, again, will differ based on the version of Windows we are targeting, as well as the kernel exploit that's being used. Now, as for the tools and the environment that I'm going to be using to demonstrate, the kernel exploitation process, we are going to be utilizing a tool called the Windows Exploit Suggester. This is a Python tool that compares a target's patch levels against the Microsoft Vulnerability Database in order to detect potential missing patches on the target. It also notifies the user if there are public exploits and Metasploit modules available for the missing bulletins or for the missing patches. All right, so the GitHub repository has been linked to this particular slide. And of course, I'll be showing you how to get the tool set up and how to use it. And then we have another GitHub repository called Windows Kernel Exploits. This is essentially a collection of Windows kernel exploits sorted by CVE. And the great thing about this GitHub repository is it actually sorts out the actual kernel exploits based on CVEs or the Microsoft Vulnerability Identification ID, or the Microsoft Vulnerability ID. So in this case, the link I've posted is a link to the MS16-135 vulnerability, which is a kernel or a vulnerability within the Windows kernel that allows for local privilege escalation, right? And we'll be taking a look at how to do this both automatically with Metasploit as well as manually. All right, now it's very important to note that the techniques demonstrated in this video are performed on a Windows 7 Service Pack 1 virtual machine. And of course, if you already should have noticed, this particular lab or this particular video doesn't have an associated lab environment. The reason for that is because kernel exploitation is extremely nuanced, depending on the type of target that you're dealing with. And the objective of this video is to show you the tools that you can use to enumerate vulnerabilities within the Windows kernel for a specific version of Windows. And secondly, I'll take you through the process of how you can, take a look at the exploit code, how you can compile it, how you can transfer the actual compiled binary or executable onto the target system, and how to execute it. And of course, this will essentially encapsulate the privilege escalation process through the use of a Windows kernel exploit. So I'm going to switch over to my Kali Linux VM, and we can begin the kernel exploitation process for Windows. All right, so I'm back on my Kali Linux virtual machine, and I've already gained access to the target system. So I'm currently within the Metasploit Framework console, and if I say sessions, you'll see that I have a PowerShell session on the target as well as a Meterpreter session. So there we are. You can see it's running Windows 7, and the user account that I currently have access to is the accountant user. So again, if I say sessions 3 to interact with that session, and I type in get use ID, you can see that it's I'm currently logged on as the accountant, and this particular account does not have elevated privileges. And I can actually demonstrate that by saying get privs. And if I hit enter, you can see that the amount of privileges that we have is extremely limited, and we essentially want to elevate our privileges to anti-authority system, right? So again, depending on the type of access you have on the target, whether it be through a Meterpreter session or a typical command shell session, it really doesn't matter. We're going to start off by taking a look at how we can identify kernel, vulnerabilities within the Windows kernel with Metasploit first, right? So I've already obtained a Meterpreter session. And of course, many of you who have used Metasploit before know that there is an inbuilt Meterpreter command that allows you to automatically elevate your privileges on the target system. And that command is just get system, right? And if I hit enter, it would essentially go through a plethora of techniques in order to elevate the privileges. And in this case, you can see that all of them have actually failed. So it tries, various techniques like token duplication, named pipe impersonation, etc., etc., and all of these fail. Well, let me just put this Meterpreter session in the background. There is a really, really useful Metasploit module that will essentially enumerate all vulnerabilities pertinent to this particular version of Windows. And the name of that module is, I'm just going to search for a module called Suggester. And this is the module here. You can see that it is a post-exploitation module, and it's called Local Exploit Suggester, right? And it works for multiple operating systems, whether it be Linux, Windows, Mac OS, etc. So I can say use this module here, and if we show the options here, you have the ability, because this is a post-exploitation module, you need to specify the session that you want to run this module on. So in this case, I've already set the session to 3, which in my case is the Meterpreter session. If I can actually type that in, you can see that that is the case. And all you need to do is hit run. This will bring up or will essentially enumerate all the vulnerabilities within this particular version of Windows. And furthermore, it will display the Metasploit modules that you can use to elevate your privileges. So again, the best way to show this is, or to actually demonstrate this, is to just hit run. And it's going to say collecting local exploits for x64 Windows. So give this a couple of seconds to a couple of minutes, as will I. So I'm going to just wait for this to complete, and I'll get back to you when it's done. All right, so the local exploit suggester module is complete, and you can see it's going to tell you 31 exploit checks are being tried. And then it'll provide you with a list of exploit modules that you can use to elevate your privileges, right? So, starting off, we have the typical bypass UAC exploit module, which we will be covering later on in this section, when we'll be taking a look at how to elevate our privileges through through bypassing UAC. And then you have a few others here, like, for example, the Shellevator exploit, as well as this one right over here. So, again, this particular exploit or these particular exploit modules, again, can be used if you've performed enough research on them in regards to what versions of Windows they will actually be successful on. So, for example, I can search for this I can search for it on Google here. So I'll just open up my browser, and I'll just paste that in there. And I can utilize the links here, for example, the Rapid7 link, to learn more about what this exploit does, or this particular exploit module does. So you can see this is Rapid7. Rapid7 is the company that developed the Metasploit framework, or rather acquired the Metasploit framework, and is currently responsible for developing it. So you can see that this module exploits the Task Scheduler 2.0 XML 0-day exploited by Stuxnet. When processing task files, the Windows Task Scheduler only uses a CRC32 checksum to validate that the file has not been tampered with. Also, in a default configuration, normal users can read and write the tasks files that they've created. By modifying the task file and creating the CRC32 collision, an attacker can execute arbitrary commands, right? So this really isn't a kernel exploit. So if we take a look at this one right over here, MS16014, and let's just search for this here. I'll just paste this in here and we'll perform a Google search. So we'll open up the Rapid7 link right over here. All right, so there we are. You can see that this exploits the Windows WMI subsystem. And you can see right over here, this module has been tested on vulnerable builds of Windows 7 Service Pack 0 and Windows 7 Service Pack 1 64-bit, right? So this might be a good starting point. And of course, if we want to use it, we can simply just copy the exploit name, the exploit module name here, and we'll hit use and paste that in there. There we are. So it's going to use the default payload, which is a 64-bit version of Meterpreter. So I'll say show options. We need to specify the actual session. So we'll say set session, and I'm going to set my Meterpreter session as that is the session I want to run this particular exploit module on. There we are. And then I need to specify my L port option because my sessions are currently using one of these ports. There we are. So my PowerShell session is currently using port 4444. So I'll say set L port to maybe 4422, and then I can hit exploit. So let's hit enter. All right, so it looks like this was successful. So it's going to say reflectively injecting the DLL into process 3 to 40 or the process ID 3 to 40. Exploit finished, waiting for hopefully privileged payload execution to complete. So it's going to send the stage, and hopefully the stage is executed on the target, and we consequently receive a Meterpreter session with elevated privileges. So again, the reason I'm demonstrating this is to show you that whenever you're using, Metasploit modules for the purpose of local privilege escalation on a Windows target, the process can be a little bit tedious in regards to your chances of success. And the reason for that is fairly simple. And of course, it all comes down to your ability to identify, vulnerabilities within this specific version of Windows that you're targeting. In this case, we get a Meterpreter session. And if I say get use ID, you can see that it is privileged, and we've successfully been able to elevate our privileges by utilizing a kernel exploit for this specific version of Windows 7. Right now, this is how to do it automatically with Metasploit. You can see that it's fairly straightforward. You can utilize just one module to enumerate a list of exploit modules that you can use against this specific version of Windows. And using the exploit module is fairly simple. You just need to set the session ID as well as the payload options like your IP addresses as well as the port that you want to listen on. Right, so I'll put this in the background. There we are. And if I list out my sessions again, you can now see I have Meterpreter, my Meterpreter session 3, which is unprivileged, and then I have another Meterpreter session which is currently privileged, and we're just going to maintain access to both of them as we are now going to perform manual privilege escalation, right? So I'm going to switch over to session 3, which is unprivileged, and of course I'll verify that that is the case. Get UID, we're currently logged on as the accountant, right? So this is where we can start exploring tools like the Windows Exploit Suggester. All right, so as I said, the GitHub repository or the link to this GitHub repository is posted in the slides. And if we take a look at the description, you can see, as I mentioned in the slides, this tool compares a target's patch level against the Microsoft vulnerability database in order to detect potential missing patches on the target. It requires the system info command output from a Windows host in order to compare that to that of the Microsoft Security Bulletin database and determine the patch level of the host. So what this means is that firstly, you need to clone this repository. As you can see, it's a Python 2 script. You then need to run the script with the update flag that will download the Microsoft vulnerability database, and it's going to be stored in an XLSX file format, right? After which you can then run the Windows Exploit Suggester Python script, specify the database that you just downloaded, right? And that of course is the vulnerability database. You then need to specify the system info argument and then specify a text file that contains the system info or the output of the system info command that you've obtained from the Windows target. All right, so if I have already cloned this repository on my system, and let's get started firstly by getting the actual system info output. So I currently have access via Meterpreter, and I'll just open up a shell session here to obtain a Windows command prompt. or a Windows command shell session. There we are. So you can see that's a command shell session, and I can then say sysinfo or system info rather, and we'll hit enter. And this is the information that you need to copy into a text file. So the reason this information is very important is because it actually contains a list of hotfixes that have been installed right over here. And based on this, the Windows Exploit Suggester will determine what exploits can be used against this specific version of Windows with these hotfixes installed, which is fantastic. So I'll just copy this information like so. There we are, copy. So I'll just copy it there, and what I'll do is I'll terminate that channel, and I'll go back into my interpreter session, and I'll open up a new terminal here, and I'll head over onto my desktop, and I'm going to create a new text file with Vim. So I'm going to just call this windows7.txt, and within this file I'm going to paste in what I copied. There we are. You can see all the information has been copied successfully. I'll then write and quit, and you can see that it's stored on my desktop right over here. All right, so now that we have that, I'm just going to navigate to the directory where I stored the Windows Exploit Suggester script, or where I cloned the GitHub repository to, which is under, in my case, under Windows enum, and then Windows Exploit Suggester right over there. All right, and as I said, within this particular directory, disregard these txt files here, as these are txt files that contain system information for my previous engagements. So you'll really just have the Python script here. You'll not have the database at all. So in your case, during your first run, you want to run Windows Exploit Suggester.py and then update, right? And that's going to download a new vulnerability database. There we are. You can see it's going to be written to the latest date, or the date where when you actually ran the command. In this case, I'm recording this on the 26th of December 2021. So in order to run this now, I can simply say Windows Exploit Suggester.py, and then I specify the database, right, which in this case is going to be the latest one. So that I'm going to say 2021, and we're currently in December, so December the 26th, and then I specify the system info file, which we just created, which is stored on my desktop under the name windows7.txt, and that's pretty much it. So once you hit enter, it's going to say initiating Winsploit. The database file detected as XLS, and it's then going to essentially enumerate a list of vulnerabilities here that this particular version of Windows is vulnerable to. So there are quite a few in this case. Now, in this particular case, or in the case of this tool, the exploits listed at the very top are the ones that have the highest chances of successfully being exploited. So let me just zoom out a little bit here so the text, so the actual text is rendered correctly. You can see right over here the system info input file read successfully, querying the database file for potential vulnerabilities, comparing the two hotfixes against the 386 potential bulletins with a database of 137 known exploits. And then, of course, you can see that it'll sort it based on the exploit DB proof of concept code, and that can be identified using the E option. If you see the M option, that tells you that there is a Metasploit module available. And if there is an asterisk, that tells you that there is a missing bulletin. All right, so starting off with the first most vulnerability, this is the MS16-135 vulnerability. So it gives you a bit of a description here. It says this is a security update for Windows kernel mode drivers. So this is indeed a kernel exploit or a vulnerability within the Windows kernel. And you can see it provides you with exploit DB code here that you can use to essentially exploit the target, as well as a GitHub repository that contains more information about this particular exploit or this particular vulnerability. And then, of course, this has the CVE code. So this vulnerability was discovered or disclosed in 2016, as we can tell from the Microsoft Vulnerability ID as well as the CVE code here. If we take a look at the exploit DB code, we can see that in this particular case, this is for the Microsoft Windows kernel, and this allows us to perform privilege escalation right over here. So We can learn more about this exploit by copying the Microsoft vulnerability ID there and, just performing a quick Google search on it. There we go. So we can click on the GitHub repository here, which I wanted to demonstrate. So I already have the Windows kernel exploits GitHub repository opened by SecWiki. This is a verifiable source of Windows kernel exploits that actually contains a list of Windows Windows kernel exploits, as well as the actual CVEs. So if I just take a step back here, you can see that they're sorted based on CVE as well as the Microsoft vulnerability identifier code. And in this case, we're looking for the MS16135 exploit. So MS16135, there we are, that's the one here. And the great thing about this GitHub repository is it provides you with the C code that you can actually go through and verify that indeed this particular executable or this particular exploit code does what it's supposed to and isn't doing anything malicious, right? Which is why I'm recommending it to you. And you can then utilize this code and compile it yourself. I will not be covering the actual compilation of exploits within this course. As I said, I'll be working on that in another course where we'll be taking a look at exploiting Windows from the context of buffer overflows and how to write your own exploits. In this case, we'll be utilizing the pre-built executable right over here, so 41015.exe. And the documentation for this vulnerability provides you with information regarding how to use it. You can see it tells you this exploit works on all 64-bit vulnerable targets, and we can essentially obtain a system shell. So in this case, it's utilizing the PowerShell script, which you can also utilize. All you need to do is just execute it, and after which it'll then provide you with an elevated command shell session. And it provides you with instructions for multiple versions of Windows, ranging from Windows 7 to a specific version of Windows 10. All right, so to use this exploit, I'm just going to download the pre-built binary or the compiled binary here. So I'll click on that here, and we'll give this a couple of seconds. All right, we'll then click on download, and I'm just going to save it within my downloads directory. So we know that this specific version of Windows that I'm targeting is vulnerable to this particular exploit. So realistically, all I need to do is transfer this executable onto the target system and execute it, and I should have elevated privileges. Now, it's very important to note that this, again, really does not take into consideration antivirus detection. So you have to be very cognizant of that. As I said, we'll be covering antivirus detection in its own, or bypassing antiviruses in its own course, because that is, quite a lengthy subject, one that I cannot cover in depth right now. All right, so again, you can go through the list of vulnerabilities displayed or enumerated with the Windows Exploit Suggester, and you can take a look at some of the other vulnerabilities and exploits, and you can test them out for yourself. In my case, what I'll do is I'll use my Meterpreter access to upload this into the temp directory within the Windows system. So the temp directory is stored within the root of the Windows file system, so I can navigate to the root of the C drive, and then I can create the temp directory if it doesn't exist already. However, in this case, if I list out the contents of the C drive, you can see we have the temp directory right over here. So I can navigate into the directory, into the temp directory. All right, so I'll say cd temp. There we are. List out the contents of the temp directory. We have nothing within that directory, right? And the reason why I'm using the temp directory is because you never want to use the home directory of a user account, because if you're transferring your exploit code or exploit files into a directory that's frequently accessed by legitimate users on the target system, then there's a good chance that you'll be detected. So always store any files that you're transferring onto a Windows system into the temp directory, and the same goes for Linux systems, and we'll be exploring that once we get there. So I can say upload, and we downloaded the pre-built or pre-compiled exploit or executable in the downloads folder. So I'll say upload that particular executable. There we are. So that's uploaded, and I can now say shell. And again, I've utilized this particular kernel exploit before, and it really is effective. And in my experience, it hasn't crashed any Windows system that I've run it on. Using it is fairly simple. If I say dir, you can see it's successfully been uploaded. To execute it, we'll just say we'll execute it through the Windows command prompt. So I'll say 410.15.exe. And if I hit enter, you'll see that it will provide me with documentation as to how to use this particular kernel exploit. So it says, please enter an operating system version. The following operating system versions are supported: Windows 7, Windows 8.1, Windows 10 prior to build release 14393, and Windows 2012, Windows Server 2012 R2. So to use it, you simply just execute the executable and specify the version of Windows that you're exploiting. So again, I can simply just say 410.15.exe, and of course you can rename this to anything you want, and I can hit 7. I'll hit enter. Now don't worry if it doesn't give you any output. This is exactly how this works. So I'm going to give this a couple of seconds to actually complete, after which you should be provided with a command shell session with elevated privileges. Alright, so after a couple of seconds, you'll see that you'll be provided with a new command shell session here. And I can simply say, who am I? And you can see NT authority system. So we've successfully been able to elevate our privileges by utilizing a kernel exploit that we obtained from a public source. And of course, as I said, you can also utilize the Metasploit framework, and that will automate this entire process. But as you can see, if you perform it manually and you enumerate the vulnerabilities that affect the specific version of Windows that you're targeting, you'll be able to get a much broader scope in regards to what types of exploits are available for you, or what types of exploits are available at your disposal, right? So as I said, definitely try out or experiment with this within your own home lab. I would recommend downloading the Windows VMs, or multiple versions or multiple releases of Windows from the Microsoft website. They allow you to download the VMs for free, and the licenses are limited for 90 days. So you can download multiple versions and test kernel exploitation on both of them, or on all of these versions. Now, as I said, I really don't recommend running kernel exploits in a production environment or in an enterprise environment unless you've tested them, as I have just done with this particular kernel exploit. And I do know that it is relatively stable, and I haven't experienced any crashes with it before. All right, so this is going to conclude the practical demonstration side of this video. All right, so now that we've explored kernel exploitation on Windows, we can move on to the next privilege escalation vector that we can use on Windows systems, and that of course is bypassing UAC, or bypassing user access control. And again, that is one of my favorite privilege escalation vectors, and you'll see why. So I'll see you in the next video.